multi-step equations, which means now there's not just one or two steps, but now we can have any amount of steps. So what was our rule last week? If we wanted to solve an equation, how did we know what to do first? What was our process? Right? Order of operations backwards. Okay, so we're undoing addition and subtraction, we're undoing multiplication and division, we're undoing exponents, we're undoing parentheses. However, as equations get more complicated, doing order of operations backwards can sometimes lead to a few pieces we need to make sure we take care of that could fall at different places. Okay, so what I'm going to do is sort of give you some steps that you can think through each time. Okay, do I need to do this, yes or no, and then complete it. What I am not giving you, can you take that out for me when I'm saying this? What I'm not giving you is something that is the only way you can solve an equation. The real rule is order of operations backwards. I'm just helping you get some thoughts and some order to that process of doing order of operations backwards, okay? So step number one when we are solving a multi-step equations is that if there are parentheses, we are going to distribute. That doesn't mean you can't solve an equation if you don't distribute first. It means your life will probably be happier if you see parentheses and then you distribute. So from last week, do we remember what the distributive property told us to do? What did it say?
To like give out.
Right, to pass out. So we have our very basics with the distributive property that say something like this. This is the one that hopefully we would all say, oh yeah, I've seen this for multiple years. Can we all agree with that? We've seen this like parentheses with a number in front, and we've been looking at that since like 7th grade. Okay, so when we pass that out, we're doing this with multiplication. So we would go here and we would multiply. So 4 times 2x gives us what? 8x. Okay, we're just multiplying the two big numbers. Does anybody know what this 2 is officially called? It starts with a C. A coefficient, right? So 4 times 2, this 2 is the coefficient. We just multiply those together and the 8's just sort of still there, right? So that becomes an 8x. What number is this right here? -7. Do you have to think about this as -7? No. How much does Mrs. McKinney recommend it? A lot. Okay, so 4 times -7 is what? -28, and that negative fills in the sign for us. Okay, and then my students go, but Mrs. McKinney, isn't that a subtraction? Well, yes, right? Subtraction and a negative are the same thing. It's just based on context and how we read them. Now, the distributive property can get a little bit more complicated if it falls somewhere within an equation and other things are happening. Like, this. (6y minus 3 minus 2y). Okay, that 3 minus 2y in parentheses. We want to make sure when we are distributing, we are actually distributing the thing that gets distributed. And my students' eyes like to wander a little bit further than they should away from those parentheses. We always distribute what's sitting directly in front of the parentheses. So right here we see parentheses. So if we want to distribute, we want to look directly Don't go this far. This is too far. And what number is sitting right here?
1.
Not just 1, but -1. Because just like I said up here, we want to make sure that that entire piece is coming with it. That subtraction is telling us the sign of the number. So we need to distribute a -1. So what is -1 times 3? -3. And what is -1 times -2y? Positive, right? A negative times a negative makes a positive. And so we will write down positive 2y. And then that is then an addition sign because positive and addition, right, are the same thing based on context. Anything else that might be happening in an equation at the same time would just come straight down and still be part of it. Now, this right here is not an equation. Why is this not an equation? What is it missing? An equal sign, right? We said equations have equal signs. Does anybody know what it's called if it doesn't have an equal sign?
An expression.
An expression. So those are just, right, some good terms to know. So that's step 1. If we see parentheses, we are going to distribute. Step 2 says if there are like terms, we are going to combine them. So if there are like terms, we are going to combine them. Again, this step is not a requirement all the time, but it's just easier when my students don't have 14 numbers floating around if we can add or subtract them all together and make them something simpler. Okay, this step basically says simplify what you can simplify. So if we see something that says (4w minus 8 plus 2w minus 6. Okay, if we see that on one side of the equal sign, I mean, yes, we could deal with some individual pieces before we actually have to combine, but if we can get it as simplified as much as possible, it's A, less overwhelming, and B, less steps. Right? We all love that, less math work. So we are going to decide what like terms we can combine. So does anyone say if they look up here, they see some like terms that they could combine? Kaylee, what do you say you could combine?
4w plus 2w.
Okay, so Kaylee, you even said the right operation here. How did you know that that was a plus 2w and not a minus? Right, you always look in front. In front, in front. So a positive 4w plus 2w gives us what? 6w. Your calculator will not allow you to type in variables, but if you're like, I'm really just so bad at my operations, it gets me every time, just put 4 plus 2 in your calculator and then bring the w with it. I would rather you do that than get a wrong number. Anything else up here that we can combine? Braden, what do you say?
-8 minus 6.
Okay, so -8 minus 6, right? We're always looking in front, so those are the correct operations as well. So -8 minus 6 gives us what?
-14.
-14. I heard the calculator's clicking, so if you use the calculator, that's fine too. Okay? And so all of those 4 pieces, these 4 specific pieces we call terms, get shortened up into 2. And that usually makes my students happy. Are we okay on that step?
Okay,
Yes.
so the actual answers are like 6W minus 4.
Well, keep in mind this doesn't have an equal sign yet, so we can't talk about an answer. This would be taking care of this step on one side of the equal sign.
So you'd be like asking like simplify the expression.
No, there'll be more stuff with it in a minute. So just hang on to that thought. I'm just sort of focusing in on one piece. Step 3 says if there are, write that down, and then leave it blank, because we're not going to talk about the rest of step 3 today. I want you to know that you have a step 3 and they're started. I want you to leave about as much space as you left for your one beforehand for step 2. So like, 5, 6 lines in your notebook. So today's step 3 just says, if there are, ... we'll fill in the rest tomorrow. And leave some blank space in your notebook. And then we're going to go to step 4. Tomorrow, the deal is tomorrow we don't have to start over and do all of the list again, so we're just going to leave some space and add to it so that we don't have to take a whole lot of notes tomorrow. It makes everybody happy. Step number 4 says if there is a large fraction so remember that large fraction was sort of my made-up word for anything that had multiple things in the numerator, right? So anything like this, right? There's multiple things up there, so there's really parentheses. We just don't write them. It's assumed they're there. Okay, so if there is a large fraction, we sort of have 2 pieces we need to take care of. No, A. I know how to take notes correctly, right? Just like you would do in English class. Okay, the first thing you're going to do, step A, is going to be to isolate it. Right? That's really sort of the math term we use, but isolate means to get it by itself. And usually at this point in the notes, my students are like, oh my gosh, these are going to be long problems. But keep in mind, we're not going to have all of these steps in every problem. It's just sort of taking care of anything we might see with any type of equation, so we would know a process to go through to use order of operations backwards. Okay, so we're going to isolate it or get it by itself. We're going to get that large fraction by itself. And then we're going to multiply by the denominator. Is the denominator the top or the bottom of the fraction? Bottom. Excellent. How many of us are tired of hearing vocab already? Not yet? How many of you feel like your teachers have used vocab in the past and you're like, I don't even know what they're talking about? We feel like we're still okay? Okay, you let me know if there's something we need to because I can always make Quizlets or something too with some of those terms to make sure we know them. I don't want the language to be an issue. So let's just say we were given a problem. We're not going to solve this completely. However, this is something we should be able to do by Thursday. 2x plus 4 all over 3 minus 7 equals 10. Okay, so if we were to look at this, there's no parentheses, so step 1 we don't need to do anything about. There's no like terms we can combine, so we don't need to do anything with that. Step 3 we don't even know. Step 4, is there a large fraction in this problem?
Yes.
Yes. Where is that large fraction happening?
2x plus 4 over 3.
Here's my large fraction. So this step says, if we have one of these things, our first objective is to get it by itself, to isolate it on one side of the equal sign. So if I look over here on this side of the equal sign, do I have stuff that I didn't highlight? Yes. How do we undo subtracting 7? Adding 7. Okay, so our first step to isolate it would be to add the 7. Like I said, we are not going to solve this whole thing. I just want to make sure we're understanding these two steps. And then part B says to multiply by the denominator. So what's our denominator? So that would be our second step. We could obviously calculate that and cancel and solve from there, but that's what we get for now. We'll do more in a little bit. How are we doing so far? Thumbs up, thumbs down, so far so good? Hang in there. The last two steps are easy. We're home free after here. Step 5 says to undo any addition and subtraction. We've already talked about that. We've done an entire day on that, so we're not adding any examples there. Step 6 says to undo any multiplication or division. Okay? So all of those steps are a giant way for you to have something that lets your brain process the steps of solving an equation. So let's say we were asked to solve this. What I notice most commonly with my students is that when something looks long, they associate it with the word hard. Okay, they look at this, they see, oh my gosh, ooh, I can't do that, turn the page. So the steps are gonna help your brain focus on one small piece. Let's not look at the problem as a whole, but let's look at the problem in smaller pieces that our brain does know what to do with. So step 1 says if there are parentheses. Does this problem have parentheses?
Yes.
Yes. What does it tell us to do if there are parentheses?
Distribute.
Distribute. So we're going to do that. We're going to ignore all of this, and we're going to focus right here. Okay, who cares that there's an equal sign? We're just focusing on this small piece. So 3 times 2b gives us what? 6b. And 3 times negative 8 gives us what? 24. So we've dealt with the parentheses, sort of like Tetris, everything else just falls straight down. Okay, so minus 4b equals 16. I know, you have to like show nice fancy work, and oh, it's so annoying that Mrs. McKinney makes me show it. Your life will be happier in the long run. Then we're going to go to step 2. Step 2 says if there are like terms. Do we have any like terms?
Yes.
Yes. So if there are like terms, which we see some right here and right here, what are we going to do with those? What does it say to do?
Combine them.
Combine them. So what is 6b minus 4b?
2b.
2b. Everything else that's left just falls straight down. Step 3, we're skipping. Step 4, if there is a large fraction. Is there a large fraction? No. So skip that step. Step 5, undo any addition or subtraction. Do we have any addition or subtraction to undo? Sure do. How do we undo subtracting 24?
Addition.
We should know how to do this because this is what we've been practicing, right? Step 6, undo any multiplication or division. Do we know how to undo multiplication or division?
Yes.
Or do we have any to undo? Yes. How do we undo multiplying by 2?
Divide by 2.
Divide by 2. B equals 20.